It's improbable that 277 volts lighting panels were implemented with incandescent lights in the early 1920s. Incandescent lights during that era typically operated on 110 to 120 volt circuits. The proliferation of 277 volts lighting panels occurred later with the introduction of fluorescent and metal halide lighting systems. These lighting technologies necessitate a higher voltage for efficient operation, and 277 volts emerged as a conventional selection for commercial installations. Consequently, it is more probable that the 277 volts lighting panels encountered in the aged edifice were integrated subsequently as a component of an enhancement or refurbishment endeavor. Delving into the evolution of electrical systems within structures unveils a fascinating trajectory of technological advancement. The initial deployment of electricity in buildings predominantly centered on incandescent lighting. These early systems were designed around the voltage standards of the period, primarily 110 to 120 volts, catering to the operational parameters of incandescent bulbs. As technology advanced, innovative lighting solutions such as fluorescent and metal halide lights entered the market. These novel lighting technologies demanded higher operating voltages to achieve enhanced energy efficiency and illumination levels. The emergence of 277 volts lighting panels signified a shift in electrical infrastructure design, enabling the efficient delivery of power to these high-voltage lighting systems. The retrofitting of older buildings with 277 volts lighting panels represents a strategic upgrade to accommodate contemporary lighting technologies. This modernization process entails the installation of new electrical panels, wiring, and control systems capable of handling the increased voltage requirements. Such upgrades not only facilitate the adoption of energy-efficient lighting solutions but also contribute to improved illumination quality and reduced energy consumption within the building. The transition from incandescent to fluorescent and metal halide lighting marks a significant milestone in the evolution of illumination technology. Incandescent lights, while providing a warm and familiar glow, are notably energy inefficient, converting a substantial portion of their energy input into heat rather than light. Fluorescent and metal halide lights, on the other hand, offer significantly higher energy efficiency, producing more light per watt of energy consumed. This enhanced efficiency translates to lower operating costs and reduced environmental impact, making them attractive alternatives for commercial and industrial applications. The adoption of 277 volts lighting panels has facilitated the widespread deployment of these energy-efficient lighting technologies, contributing to a more sustainable and cost-effective approach to building illumination. Furthermore, the integration of 277 volts lighting panels into building electrical systems necessitates adherence to stringent safety standards and regulatory requirements. Electrical installations must comply with established codes and guidelines to ensure the safe and reliable operation of the system. Qualified electricians and electrical engineers are essential for the design, installation, and maintenance of 277 volts lighting systems, guaranteeing that all work is performed in accordance with industry best practices. Regular inspections and maintenance are crucial for identifying and addressing potential issues, preventing electrical hazards, and ensuring the longevity of the lighting system. The evolution of lighting technology and electrical infrastructure reflects a continuous pursuit of efficiency, safety, and sustainability. The transition from low-voltage incandescent systems to high-voltage fluorescent and metal halide systems powered by 277 volts lighting panels represents a significant advancement in building illumination. By embracing these advancements, building owners and operators can achieve enhanced energy efficiency, improved lighting quality, and a safer, more sustainable built environment. The use of 277 volts for lighting circuits is common in commercial and industrial buildings for several reasons, particularly related to efficiency and cost effectiveness. Firstly, voltage drop is a critical consideration in electrical systems. When electricity flows through a wire, there is a loss of voltage due to the wire's resistance. This voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. Higher voltages, like 277 volts, allow electricity to be transmitted over longer distances with less voltage drop compared to lower voltages like 120 volts. This is because for the same amount of power, a higher voltage results in a lower current. Since voltage drop is directly proportional to the current, reducing the current reduces the voltage drop. Secondly, conductor size and cost are also important factors. The size of the wires needed to carry electricity is determined by the amount of current. Higher currents require larger, more expensive wires. By using 277 volts instead of 120 volts, the current required for the same amount of power is reduced. This means that smaller, less expensive wires can be used, resulting in significant cost savings, especially in large buildings with long wiring runs. Thirdly, transformer efficiency plays a role. In many commercial buildings, the incoming power from the utility company is at a higher voltage, such as 480 volts. This voltage needs to be stepped down to low voltages for various uses. Using 277 volts for lighting allows for a more direct transformation from 480 volts, often simplifying the electrical distribution system and improving overall efficiency. Transformers are most efficient when they are fully loaded, and using 277 volts for lighting helps to better utilize the transformer's capacity. Fourthly, lighting efficiency is also enhanced. Many modern lighting systems, such as fluorescent and LED fixtures, are designed to operate efficiently at 277 volts. These fixtures often include internal bus or drivers that convert the 277 volts AC power to the appropriate voltage and current for the lamps. Operating these fixtures at their designed voltage ensures optimal performance and longevity. In contrast, using 120 volts for high-intensity lighting would require more circuits and more complex wiring, increasing costs and complexity. Fifthly, safety considerations are paramount. While working with higher voltages requires greater caution, 277-volt systems are designed with safety features to protect personnel and equipment. Grounding systems, circuit breakers, and other safety devices are essential components of these systems. Properly installed and maintained 277-volt systems are safe and reliable. In the context of older buildings, the presence of 277 volts lighting panels suggests that the electrical system has been upgraded at some point to accommodate more modern lighting technologies. Original lighting systems in buildings from the early 1920s would have almost certainly used 120 volts for incandescent lighting. The introduction of 277 volts systems would have coincided with the adoption of fluorescent or metal halide lighting, which became more prevalent in commercial buildings in the mid to late 20th century. In summary, the use of 277 volts lighting panels in commercial and industrial buildings offers several advantages, including reduced voltage drop, lower conductor costs, improved transformer efficiency, enhanced lighting efficiency, and compatibility with modern lighting technologies. While it is unlikely that 277 volts lighting panels were used with incandescent lights in the early 1920s, their presence in an older building indicates that the electrical system has been upgraded to support more efficient and modern lighting solutions. When considering electrical upgrades in older buildings, it is essential to assess the existing electrical infrastructure and determine the appropriate voltage levels for different applications. Consulting with qualified electrical engineers and contractors is crucial to ensure that the upgrades are performed safely and in compliance with all applicable codes and standards. This includes evaluating the capacity of the existing electrical panels, the condition of the wiring, and the grounding system. Upgrading to 277 volts lighting can provide significant benefits in terms of energy efficiency and cost savings, but it must be done carefully and professionally to ensure the safety and reliability of the electrical system. Furthermore, understanding the historical context of electrical systems and buildings can provide valuable insights into the evolution of technology and the changing needs of building occupants. By examining the original electrical plans and records, it is possible to trace the history of electrical upgrades and modifications. This information can be helpful in planning future upgrades and ensuring that the electrical system meets the current and future demands of the building. In addition to the technical aspects of 277 volts lighting systems, it is also important to consider the aesthetic and functional aspects of lighting design. Proper lighting can enhance the appearance of a space, improve visibility, and create a more comfortable and productive environment. When upgrading lighting systems, it is important to select fixtures that provide the appropriate level of illumination, color rendering, and distribution for the intended use of the space. Energy-efficient lighting technologies, such as LED lighting, offer a wide range of options for achieving these goals while also reducing energy consumption and operating costs. In conclusion, the use of 277 volts lighting panels represents a significant advancement in electrical technology that has enabled the widespread adoption of energy-efficient lighting solutions in commercial and industrial buildings. While it is unlikely that 277 volts lighting panels were used with incandescent lights in the early 1920s, the presence in an older building indicates that the electrical system has been upgraded to support more modern lighting technologies. By understanding the historical context of electrical systems and carefully planning electrical upgrades, building owners and operators can ensure that their buildings are safe, efficient, and well lit. The evolution of lighting from incandescent bulbs to modern LED systems is a testament to ongoing advancements in technology and a commitment to sustainable energy practices. The transition to higher voltage systems like 277 volts reflects a broader trend towards greater efficiency and cost-effectiveness in electrical power distribution. As technology continues to evolve, further innovations in lighting and electrical systems are likely to emerge, offering even greater opportunities for energy savings and improved performance. The key to maximizing the benefits of these advancements is to stay informed about the latest technologies and best practices, and to work with qualified professionals who can provide expert guidance and support. In summary, the progression of lighting technology from the early 20th century to the present day showcases a remarkable journey of innovation. The shift from low-voltage incandescent systems to high-voltage fluorescent metal halide and LED systems has been driven by the need for greater energy efficiency, lower operating costs, and improved lighting quality. The adoption of 277 volts lighting panels has played a crucial role in this evolution, enabling the efficient distribution of power to these modern lighting technologies. While the presence of 277 volts lighting panels in an older building suggests a subsequent upgrade, it is essential to consider the historical context and carefully assess the existing electrical infrastructure before undertaking any further modifications. By working with qualified professionals and staying informed about the latest technologies, building owners and operators can ensure that their buildings are safe, efficient, and well lit for years to come. Remember to always prioritize safety when working with electrical systems and to adhere to all applicable codes and standards. Electrical work should only be performed by qualified electricians and engineers who have the knowledge and experience to do the job safely and correctly. Regular inspections and maintenance are essential for identifying and addressing potential issues, preventing electrical hazards, and ensuring the longevity of the electrical system. By following these guidelines, you can ensure that your building's electrical system is safe, reliable, and efficient. Furthermore, continuous learning and professional development are essential for staying up to date with the latest advancements in electrical technology. Attending industry conferences, reading technical publications, and participating in training programs can help you expand your knowledge and skills and ensure that you are providing the best possible service to your clients. The field of electrical engineering is constantly evolving, and it is important to stay ahead of the curve to remain competitive and provide innovative solutions. In conclusion, the journey from early incandescent lighting to modern LED systems powered by 277 volts lighting panels represents a significant achievement in electrical engineering and a testament to the power of innovation. By understanding the historical context, embracing new technologies, and prioritizing safety, we can continue to improve the efficiency, reliability, and sustainability of our buildings and infrastructure.